Hi everyone. Just give me a little bit to test the audio, see that everything's going okay. Audio, see that. Okay. Yep, there we go. Okay. So let's get back to it. Now last time we found a very interesting corpora. We found an interesting set of corpora, which is WaCKy. And so I looked into it more, and it looks really good. What looks particularly good is there is a frequency list. Yes. And so what looks especially attractive is the fact that it has both unigrams and bigrams, and on top of that it has the lemmas and words for it. I think the lemmas weren't exactly as good as the words, or at least as much as I would like it to be. So what I think I wanted to do is I looked into lemmatization as well. So there is Golang, what is it? Golem. Lemmatization library. If you look at it, it's actually a very simple. It's a very simple file. It's like 100 lines. So you can literally copy and paste this into your own project, which I think I will do. Just to like reduce the dependency and stuff like that. And also, I think there was perhaps some efficiency things I wanted to do. Like, I think I just wanted a map. There's this vector, because you actually can't have multiple lemmas for a single word. But I don't really want that. Like, I'm not trying to autocomplete anything or stuff like that. What I really wanted to do for the lemmas is... So for the bigrams, there are a lot of bigrams, unsurprisingly. And so I want to reduce the number of bigrams by reducing them to their lemma instead. And so it doesn't actually matter what lemma I choose, for instance. It only matters that I choose like some lemma, and that lemma has a frequency. And yes, they are actual frequency lists. So if I go back to yes. Okay, if I go back to something. What was I going? Oh, yes. So I want to view in a new window. Yeah, so I pretty much downloaded like the actual lemma and word for both unigrams and bigrams just to have them. And so if I take a look at UK, which is basically just the English list. So UK word bigrams. I don't want to look at it through VI because VI actually sort of chokes on this data set a little. Less is a lot better with this. And so you have the frequency, you have this first word, and you have the second word. Very easy, very nice. You can just split it on spaces and it should be good. Same thing with here. You can do sorted, word, unigram. Wait, where are the unigrams again? Yeah, because I... Oh, did I not unzip the word? Yeah, okay. So I actually want to do that. So I want to use 7-zip to extract UK, or sorted, UK word unigrams. I'm actually curious how big this file is in the first place. This is... so about 187 megabytes. How much is the bigrams? I think the bigrams was like a gigabyte even, which makes sense because there are a lot of bigrams. UK.word bigrams. Yeah, so that's kilobytes, that's mega. Yep. So it was actually like 1 gigabyte. Quite a bit. And this is why I wanted to do the bigrams by lemmas, just because it's so ridiculously big that I don't want to chew up that much memory. I want to try my best to sort of squish it down, because there are a lot of words in there. And again, like, I just need, for the unigrams, I do need all the words, but for the bigrams, I don't need all the words. I just need, like, some sort of approximation. Yeah, so you can see, yep, the bigrams are much, much bigger. So if you're going to reduce that in any way, we would like to do that. And so... Oh yes, and what is Golem doing? So it mentions in the blah blah blah. Yes, it mentions in the README that what it does, yeah, there's like these lemmatization lists, so I can read them myself and do stuff with that. And I think it's very easy to read them. It's very easy to read them. You just read it line by line, and you read by line, and you have like the second word, and that's easy and good. And so I forgot if I actually like have the lemmatization list. Nope, I do not have the lemmatization list. So what I'm gonna do is download that, and I'm gonna transfer it over. Oh right, I already downloaded it. So I'm just gonna open up SFTP in another window. And then I can put lemmatization.txt. Yep, and that works. Do I need to upload anything else? So I have the lemmatization, I have the unigrams, I have the bigrams. That's it. So in reality, our program's probably going to take 3 files. It's going to take a unigram list, it's going to take a bigram list, and then it's going to take a lemmatization file. Although I don't know if I want to do the lemmatization offline. Well, it's not really an expensive process, so no, not really. Well, no, because it makes the file smaller, and then I don't have to do as much I/O. So that might be an interesting idea. I think I don't have to worry about that yet. And also, yeah, I don't know how hard that's gonna make the... Well, sure, we can... So let me pull up Git Bash again. So what we can do... First of all, here, I want to move lemmatization. Oh, do I already have it? Yeah, okay, cool. So now... Oh yes, so what I want to do is... I'm gonna do log printf, reading words, reading worlds. Words read. Go run. So it's already, yeah, it's already pretty quick. So I don't think... I'm gonna say if like doing the lemmatization and reading the corpora is like more than 2 or 3 seconds. I don't see it being that much, but if it is, then we can worry about sort of caching those results. I don't know if caching those results even is very... beneficial. We'll see. We'll see how well it goes. But yeah, hopefully that's not as bad. Okay, so I'm able to read those words there. And... oh yeah, so for read words, I think... so I returned strings and priority. I think what I rather would do is I want to do a map, actually, of string to int. And I said I didn't want to do this because I wanted to keep it sorted, but I think a better idea is actually to have this mapping, and then I make a list out of the mapping, and then I sort the list. And there's a nice sort package in Golang, so we can just use sort there. I wonder if there's a quick way to do maps to string, or maps to slices. Yeah, it's just doing range my map. Yeah, fair enough. Which makes sense. You don't really need to get it better than that. Heroes to yeah. Do, 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 do. So then what I can do is words filtered equals priority. So then what I had is this. So now instead of word list, I want word list sorted is or I can even declare it as a variable, word list. Oh, you know what? I can declare the capacity beforehand because I actually know what the capacity is. It's the length of the map. So word list sorted equals make string 0 len of word list. And so for word in range word list, you can do word list sorted. I need an index as well. I don't think, yeah, no. I think what I can do is do some scoping here. Because I don't want I to persist after this. It looks a bit weird, but it makes the scoping like I actually want it to be. Or I really don't even have to do this 0. Thing, is that how you do it? So Golang makes slice. Because I think if you give 2 parameters, it's just the length of it. Yes, that's the length of it if you give just a single parameter. So that works. And then I want to do sort dot strings word list sorted. And that's it. That's all we need to do. I said strings. Oh, okay, so that's interesting. So, doesn't exactly work how I wanted it to. Well, I think that's not a big deal. I can just give the word list and then the sorted priorities. Yeah, we can do something like this. And so words is a map string to int, and then words sorted. This is words sorted. So then I can do word in range prefixes. So I did a map there. Do I want to do a map there? No, I don't think I want to do a map there. So I can do that. And then instead in find prefixes, find prefixes. Wait, shoot, what was this before? Yeah, so prefixes is initialized with that. And that, before that was words. And so... yeah, so I don't need this priority anymore. There we go, much cleaner. Reason about this a bit better. And so I have prefixes there. I think I can change this to be instead. Yep, just a slice of string like I had it before. String. Words, low, 49. Yep, that works. I know what you want. Yep, that's nice. So I said prefix is map, it's not a map anymore. So it's not prefix prios anymore. So let's call this prefixes. Let's call this temp. We'll say remaining. Yep. Remaining. Except maybe I still want a map because I want like this set. Yeah, like I might have duplicates here. In fact, I'm likely to have duplicates here. Is there like a set? Because I know a map could be good, but I'd rather have something like an optimized set. Yeah, people are just saying use a map and then make the other thing a bool. Yep, people are just saying do a map string bool. Which is fine. Yep, you can definitely do that. Map string bool. We'll call it a set this time. So we'll say set. What I can also do? Yeah. This is actually much what I'd rather want. Yeah, this is good. Let's even have it as the same signature as our other function. Yep, it was good. It's not word prios, but now it's just words. Ah. Now I don't need that. I can test it. And then I can say words. test. And it's not a set anymore, it's a map again. Yep, there we go. So now instead of that, I can say words sorted. I can also say words here. Yep. And that looks good. Go run. Oh, right. Didn't I have... Yeah, I did. Yep. Let's do that. So, undefined priorities. Wait, when did I have a priorities? Right. What? Oh, I don't anymore. That's the thing. Alright, so there's still no priorities. So I don't want that anymore. So reading in an empty word list is an error, of course. Prefixes is undefined. And that's because it is undefined. You changed it to remaining. I could say it's prefixes again, since I have the map. Yeah, prefixes. Remaining prefixes. I don't know why I didn't do that before. Uh-oh. Assignment entry and nil map. So I forgot to make a map. Somehow. That's true. I did forget to make a map, because you make a map here. Yay! Word's red. Let's just do a basic test. Glad to know it's still crap. Okay. Really? And that's in Unix sorted? Yeah, that's what I wanted. Huh. If I remember, it's kind of weird in the other dictionaries. Shoot, I used VI. Okay, I didn't want to do that. Less. Yeah, because the number's before the actual word. Going split by space. Because I noticed maybe some of them are tabs and some of them are spaces. I'm not sure. Oh, I can just use fields. Was I already using fields? I don't remember using fields, actually. Okay, perfect. I can just use fields. And I looked that up on Stack Overflow, so... so you didn't see that, but that is what happens. You can just use fields, and this just works. I mean, first, let me actually look up the document. Let me bother to look up the documentation. Just make sure that we're doing just fine. So Golang has fields. Just a string S around each instance and one or more consecutive white space characters as defined by Unicode as space, returning this. Yep, that's perfect. That's exactly what I want. So let's go back to git bash. And so what I think I would like to do I would actually like to make this 4 arguments. Unigrams, and I want one file that's unigrams, I want one file that's bigrams, and I want a file that's lemmas. And so unigrams. I might also want to combine this list. Yeah, it might be nicer to combine the list, actually. I do want a separate lemma. I still want a separate lemma list. I'm just wondering if I want to then combine the unigrams. Yeah, we can do that. Okay. So there's unigrams, bigrams, and lemmas. What I'm thinking about combining the unigrams as bigrams is that if it has 2 fields, it's a unigram. If it has 3 fields, it's a bigram. And how many lines are in each of them, actually? I'm just curious for my own sake. So word unigrams. We got a whopping 12 million unigrams? That's wild. And for the bigrams, we got a whopping 7 million bigrams. Or 78 million bigrams? Yep, that's 78 million bigrams. Cool. I'm curious because I might log how many bigrams I use by the end of the lemmatization. Because I suspect a lot of them will be duplicates. Maybe not a lot of them, but just like a maybe non-arbitrary amount of them. Do I want a separate? I'm still wondering if I want a separate one. Because it would just be as easy as catting them to get the entire list. The thing is, I would have to sort... No, I don't have to sort them, right, because... How about we say this is n-grams? Yeah. And so one file for lemma is one file for n-grams. So that those can be a bit more independent. So what I can do is make a new function. Func read lemmas. Just so I don't forget. I doubt I would forget, but just to do lemmatize bigrams, read unigrams as is. Bigrams have 3 fields. Unigrams have 2. So this is also file name, and this is going to be a map of string to string. Again, this isn't technically proper, but for the sake of this application, it's good enough. And then I can copy a lot of the same code. Word two lemmas. Make map string to string. If error is not nil, return words to lemmas here. It might actually be better to return nil here. Yeah, it would be better to return nil here, just so I can catch when people do silly things with maps. So this wouldn't be for, and we'll keep it as 2 just so I can test it initially. Yep, okay. Yeah, so you can just return nil there, which is what I wanted. I wanted to return nil there. Defer fp.close. So I'm pretty much just gonna copy this. Fields, strings, dot fields. If fields is equivalent to 0, we'll continue. And then the lemma is fields of 0. And then for word in fields. And this includes lemma, so I'm going to say that words to lemmas of word equals lemma. And that's it. Return words to lemmas. So now I'm going to say this is 3. And this is n-grams, and this is lemmas. So log printf reading lemmas. Lemmas read. Yay. So if error is not equal nil, and I don't actually care about empty lemma, so I don't have to do like this same check here. Oh, I actually forgot. Yes, words to lemmas scanner.error. Format printf. Well, not. Yes? Yes. Format printf. Fail to read lemmas. And it's not words anymore, we say it's n-grams. I think we can sort of do this, because what I'm planning to do is I'm still planning to like return just a plain string, but with the bigrams, I'm going to combine them with like a single space. os.exit1 So now I want to test, I want to change this. Say base is actually this. So base, what is this? And grams. And it's not unit sorted. I'm gonna say this is WaCKy. WaCKy ngrams txt. Lemmas equals base. I think it was lemmatization en. Don't want this anymore. So now instead of that, I have lemmas. Or no, first ngrams, then lemmas. Ngrams, lemmas. Now push the 2. So I have lemmatization en. Oh yeah, so then cat sorted UK lemma. Well, not lemma. I actually want the words. Sorted. Or no, UK word bigrams. WaCKy ngrams txt. Yep, that's a chunky one. That took a while. Let me see what I did for the test. WaCKy ngram. Yep. So hopefully that works. Uh-oh. 34? Oh, this is true. $20? What happened here? Oh, yes. Cannot convert that to string. What did I just do? Oh, len fields. $35? Huh? Cannot use word variable type int. What are you even talking about? What does string.fields do? It does return me the... Yeah, it returns me an array of strings. What? Oh. Right. Let's say underscore because I'm not using them yet. Whoa. Oh, that's right, yes. So now... So not 0, but if it's less than 2, I don't want it. So we'll do that. So not 1 was 0. Yep. So we're doing field, so I don't think I need to trim the space there. No, don't need to trim spaces. Let's say word 1, word 2. And so word 1 equals strings dot to lower. Fields 1. If len fields is greater than 2, then word 2 equals strings dot to lower. Fields 2. By the way, let me check the unigrams again, because I think I remember. Yeah, punctuation counts. So I'll get punctuation for free. Maybe. I don't know if that's how that works, but we'll see. Ooh, we got a backslash 96. That's crazy. Yeah, I think it should still be fine. It's just, that's gonna be a bit weird. I might have to do some cleaning of this data set. I don't think I'll have to do much cleaning, but that might be a thing that I have to do. Okay. So word 2 is that, and then so if word 1 is the empty string, continue. If word 2 is equivalent to the empty string, then words filtered, or not filtered, words 1, word 1 equals priority. Otherwise, word 1 plus a space plus word 2 equals priority. And so we have a really convenient way of encoding a bigram just as a string, so I don't have to worry about that as like a special case. I can just use the same word list. Oh, you know what? I don't even have to do word 1 and word 2. I could say word strings dot to lower fields 1. And then I can then say word plus equals double quote plus strings dot to lower fields 1. Or not fields 1, but fields 2. So then words of word equals priority. That's a lot cleaner. Did I just undo that? Damn. Damn. It'd be like that sometimes. Okay, great. Oh, right, but I also wanted to do lemmatization. Maybe not right now. I actually kind of want to see how fast it is. Or, not how fast it is, but how slow it is. Because I feel like it's going to be pretty slow. But we'll see. Oh, that was the problem, I forgot. Parentheses. Yes, it's like painfully slow. Okay. Golang's trying its hardest. It's trying, man. Yup, there we go. That was painful. Hopefully with the lemmatization, it's a bit better. I don't think so, but a guy can be optimistic, right? So this is lemmas, map, string to string. Lemmas. Ugh. So then lemma 1 equals or not strings to lower, but if not okay, lemma 1 equals word 1. Okay, so lemma 2 if not okay, lemma 2 equals word 2. And so now word's going to be lemma 1 plus that plus lemma 2. Alright, let's see how bad it is. That's brutal. It might even be more computationally intensive. Yeah, that like actually takes legitimately a few seconds. I think it was a little bit faster. Yeah. Yeah, now I'm actually curious how many. So I can say %d lemmas, len lemmas. I can also say this %d words. $67,000 lemmas. Okay. Brutal. I also noticed I was doing an assignment a priority. I wanted to do a plus equals a priority. Oh, hi. Hi, Poggle. Yes, it's some Go. It's going well. How are you doing, Poggle? Okay. Yeah, jeez. Okay. Can't sleep, so I'm here. Yeah. No syntax. Yeah, no syntax highlighting. Yeah, I just not. I know a lot of people like syntax highlighting. I just never really got that much use out of syntax highlighting. Sometimes, like, even hurts my eyes too. It's weird. Yeah. But yeah, so what I'm trying to do is, so let me do it with, like, as you can see, I had like a pretty decently large word list. So I'm gonna try and use a smaller word list right now. See, the appeal just not good enough in any particular language for that. That's fair. Oh yeah, so Unix sorted. So right now I'm not using lemmas at that point. Oh, I read it in an empty word list. Why did I read it in an empty word list? Because that wasn't supposed to happen. Oh, wait, okay. So, yes, I remember now. Never mind. Nope. Oh, right, okay. So, I changed the data a bit, so before I used to be just like a sorted word list. My day is going pretty well. Yeah, I'm just sort of... I got back from work, and then I just started programming, and it's been chill so far. And so what I've been doing is... Once I actually fix everything, I'll tell you what I'm doing. So I think it's just an awk script at this point. What if I do for work? I do things in cybersecurity. Yes, so I'm mostly a cyber security person. And so it's very cool what I do, but I just can't really say a whole lot about it. Unix sorted. Yeah, so this should be good enough. Unix sorted. So now this should come out. Yes. So what I was trying to do is I was trying to make something that uncombined merged sentences. So if I do this, it failed in that case, but it's supposed to like say I love you. Or something like that. That didn't work either. Today day? Okay, yeah, so something like that. That's what's supposed to happen. As you can see, there's still a bit of kinks. And so I'm just trying to figure out how to take care of it. Yeah, so you should figure out something like that. Exactly. And so initially I was just using unigrams, but what I started to look at was, what I started to look into was bigrams. So I have a different sort of word list, and this is a word list. I shouldn't have used VI. Why did I use VI? The reason I'm sort of complaining about that is, yeah, you can see it takes like a long time to load. If I do it with less, though, it loads pretty quickly. Okay. So what I wanted to do is I have these bigrams, and so what I'm thinking is with the bigrams that if I sort of keep like a list or I look ahead by like one token, then I should get better results, because like, you know, things like ILO, that's not a very common bigram, but I love is an extremely common bigram. So I'm hoping that would actually help a lot. It's just, I think part of the problem I'm sort of facing here, which I might just bite the bullet for now, but I want to figure out how to optimize it so that if I do... So I have these n-grams, and... what was it? And the n-grams are just both unigrams and bigrams, and then I parse the file and see if it's a unigram or a bigram from there. Yeah, but you can see like it takes a long time to read the words. I think it took like, what was it last time, like 10 seconds? Who knows? We can wait, like there's a timestamp here, so I can wait a little bit and then see how much time that actually took. But while that's doing its thing, then I can pull up Chrome here. Yep. So that, okay, it actually just got done, so I'm gonna show that again. It took about like 38 seconds. That's kind of brutal. But if that's what it takes, then, you know, I take a bit of time to actually edit the code. I don't need that rapid of an iteration cycle, so that might be good enough to just sort of bite the bullet there. I don't know, though. But anyways, so what I was... Yeah, it's a lot of words. Indeed. How many was it? Yeah, 74 million. Now, what I wanted to check also... What I wanted... Okay, yeah. So I think it's nice because I was able to actually reduce the word count here, and how I was able to reduce the word count is that... there we go. Yeah, so these like sum up to like... If I had to do a quick back-of-the-envelope calculation, like 90 million words and bigrams, it seems like I was able to reduce it by a little bit by using these lemmas. And so I can look up lemmatization real quick on stream. And so what lemmatization is so there's different forms of a word, and it puts it into a single word. So if I look at this picture right now, there's like a bunch of these words. There's change, there's changing, there's changes, there's change, there's changer. And those go into the same root of change. Well, this is stemming. Lemmatization is the one on the right, which is very similar, anyways. But yeah, so... It seems like the lemmatization, like, reduced the word count, because, you know, in the bigram... I did it specifically for bigrams, and unigrams, I still wanted to do it, like, as is, because I'm using the unigrams in order to, like, see... So what I'm partially using the unigrams for is that... So what I'm doing is I'm looking at this entire sentence and I'm getting the longest prefix that I can, for the most part. So I'm looking for so, I'm looking for it, I'm looking for goes, etc. And that sort of has the results. That's why when I put I love you, oh, it's not, oh shoot, thank you, sorry. There we go, yes. So I do so, and then it, and then goes, and then etc. And that's why I have kind of bad results, is because in here I wanted to use I, but I have IL, and so then it does O, does V, E, then U, and it's not a good result. But that's sort of like my initial prototype, was just getting the longest prefix and then matching that. And it works sometimes, it doesn't work other times, but what I'm thinking is like, if I have the bigrams, then... Yeah, so if I have the bigrams, then my brain is farting. But if I have the bigrams, then yes, I should, even if I did like so it, or if I did like so it G or something like that, like this should fail because it's not a common bigram to have like OES or something like that. That's what I'm hoping anyways. But it's a large word list, which... So before, what I was using when I was just using unigrams was Unix sorted, was like, I took my little dictionary, and so Unix has like a predefined dictionary. I converted that to lowercase and then sorted it, and then just used unique entries. And so that gives me what I have here. And so what I might do is... I might go through... So this is a smaller list, so that's nice. And it's a very decent list, like it's given me good results so far, so what I might do is use this list and go through the WaCKy corpus, and which is the bigger corpus, and if it's not in this list, then I just kind of filter it out, and that should give me a much smaller list than I currently have, and so hopefully that's a better iteration cycle. I'm just wondering... It should... Like, I'm thinking this will be like... How am I handling apostrophes? Oh yeah, so apostrophes... So sometimes apostrophes happen in the word list, but how I handle apostrophes is if... I can actually show it right now. So let me switch back to the Unix dictionary. Oh, Unix sorted rated, that's right. What I might also want to do is this. Yes. So then I can do this, or probably put that at the top, and then, yeah. So what I'm doing for punctuation is that, yeah, so you can see like not all punctuation sort of matches. So what I do on non-matches is that, so we have I, comma, hey, comma, this, and so I go with I, and because there's no match here, I'll get back to it later. And so I go to the next word and it's hate, and so once I get hate, I'm like, okay, I had this comment before, now include it. And then output hate. And so I keep going with that. So that's sort of how I handle punctuation that doesn't really fit normally. Oh yes, and then for punctuation, words are usually separated by spaces, but if it's punctuation, then I decide to just merge it to like the last word and then put a space afterwards. And that's been like at least a pretty good heuristic. We go back to this. When you're matching with apostrophe, are you doing anything special or purely matching against the text file? No, I'm not really doing it. In terms of matching, I'm not doing anything special. In terms of like how I position it, that's the only special thing. Of course, well, not of course, but it happens to be the case that sometimes there are apostrophes in the word list, but I don't treat it specially. Like, if it happens to be in the word list, great. If it's not in the word list, then oh well. So read words. Yeah, so I read all these lemmas, and the lemmas seem to have worked, otherwise I wouldn't have gotten less results from that. So that's cool. Yeah, so what I was doing here was, if there's an apostrophe, you could check the second two letters, which would increase the quality of the choice. Yeah, it probably would. Right, like, you know, there's like S and then NT and stuff like that. That's true. It's just I wanted to go with that maybe a little bit less in the game. Either less in the game or I put it in the word list anyways. And like count that as like an actual word. That might, because I think that's sort of, that sometimes happens in like the actual WaCKy word list. I used VI again. Okay, so that might take some time. But yeah, I should be able to find something. But yeah, you see like there's sometimes apostrophe S right here. Yeah, so here there's sometimes apostrophe S. So it sometimes does show up in the word list, and that's actually really convenient. I think like you said, as like a backup, if that doesn't work out, then yeah, I could actually check those two letters. And that would increase the quality of the choice. It's just that's more programming, and I'm trying to like kind of iterate on this right now. Thanks for the follow. Appreciate it. I need to change that noise. I thought it would be funny at first, but it's just kind of weird at this point. Although clearly I'm still a little bit amused by it, so I don't know. Wait, another follow? Wait, who followed now? Now I want to actually see this. First, oh, okay. Nice. Oh, so Boskins and Poggle, thank you both. Okay, so what am I doing here? So there's prefixes, prefix. Oh yes. So for prefixes, so this algorithm's a little bit nasty. So what I'm doing is converting, so I'm splitting the sentence. So first I have a sentence. So when I have this prefix, I had this sort of command here, and this is my sentence. So I'm trying to split the sentence. And how I split this sentence is that I have two word lists. I have a word list with priorities, and I have a word list that's actually sorted. And I have the original sentence. And so prefixes are this. And there's a prefix. Yes, and so I have this list of prefixes here. Or where did I have the prefixes? Okay. So now I'm a little bit lost. Oh yeah, so this finds the certain... So what did I mean by prefixes? What I meant by prefixes is... So I want to find... Yes, now I remember. So I want to find all the words in word sorted that are a prefix of sentence lower. And... Or at least part of it. So what this algorithm is doing is it's looking at this and it's saying, okay, I want all the prefixes of I hate this. Or I sort of colored the Twitch chat. Let me color it in the terminal. So I hate this. So I want to look at all the prefixes of I hate this. And I want to look at all the prefixes of comma hate this. I want to look at all the prefixes of hate this. I want to look at all the prefixes of hate this. And etc., etc. It might not be efficient, but it works out so far. And so I'm finding all the prefixes there. And so what's happening there is... So I use the words in the actual sorted words. Why I'm using the sorted words is because there could be multiple prefixes and I want to find all of them. So what I'm doing is this sort of weird binary search. I found out that Golang also, it has a binary search method, so I didn't really need to inline this. But for now, it's inlined. And so now I'm checking if it's, if the word I found wasn't even a prefix, then don't use it. Otherwise, I'm looking at the range and... What is it? So with prefixes, there's like a certain optimization you can do where you can sort of see... If you're looking for like prefixes of 8, then what you can do is you have like... Prefixes of 8 are all... ATF. Yeah, so prefixes of, or words with the prefix of 8, they can be lexicographically sorted so that they're all greater than word. So that the words that have 8 as a prefix are all greater than 8, but they're also less than ATF. So that's what I'm sort of trying to do here. I'm trying to go backwards and see, okay, what's the least word that isn't a prefix anymore? And then what's the greatest word that isn't a prefix anymore? And then I'm squeezing it there so that I have all the range of prefixes. So that's how I sort of find those prefixes, and then once I find those prefixes, I have this lookup where it has words to priorities. I was initially doing priorities, I'm not doing that now. Or I will do that in the future once I do, like, you know, the bigrams, because I like, you know, that's kind of the entire point. I wanted to see what bigrams were more of a priority. So that's why I still have that. And so I'm looking for that. And right now, this is just like a one-word prefix. Eventually, I'm going to have bigram. I'm going to, like, look at bigrams. And then I'm going to actually see what are reasonable bigrams. And see the priorities there. And so, if I didn't end up finding a prefix, there's no like empty words in the word list. So if it's a non-empty prefix, then it's there. If it's an empty prefix, then it wasn't there. Which is where, like, you know, the commas come in. Like, the comma wasn't a match, but it still, like, made it in there. And so, when I get a match... Yes, then I append, like, the things that didn't match initially, and then I append the match. And so this is also a thing here where, like, if I still have some stuff at the end, then I want to append it as well. And that's basically how I do that. And then here is just like extra filtering where I'm trying to like get rid of words that are empty because I don't want empty words, which shouldn't be in the thing, but I don't know. Prophylaxis, that's what they call it. Just prophylaxis. Okay. So I'm also realizing that if I have such a large word list, it might also impact like their runtime in ways that I don't want it to. So I think what I might do is actually... Wait, okay. Oh, actually, What I just realized is that in the word list, in the word list, I'm now like sorting the bigrams, which I actually don't want to do. So maybe I might actually have like a separate dictionary that's just the bigrams. Yeah, sure. Map, string, thing. And so that's a priority of the bigrams. So this is words, this is bigrams. So I'll put an else condition here. And so this is words of word, this priority. And this is bigrams of this priority. So this is words, bigrams here. Put an extra nil here. So that works. And then I need to also change the call site here. So I'm not using it right now, so we don't care about it. Oh, that's syntax error. Okay, 154. Oh, that's true. That is the syntax error. Okay. Yep, so that works. I can also do like a quick... There we go. So that works. Just a basic sanity check. Right, so I think... Right, so I think... I might want to still use like the UK word list, because this is a good word list, but then I want to see that... I want to use just words in the Unix sorted thing. So we'll do that. At least for testing. Like in release, I'm not going to be like starting this spot a whole lot, so it's very reasonable to just say, oh yeah, I'm fine with just a 40-second startup. Just do it. But for testing, I definitely want it to be a lot quicker, so we'll do that. We'll make a quick script to... Oh, right, but again, I was saying about the runtime. We'll see in both cases. But for now, it might be worthwhile to just make a quick script that does that. I'll just do like a filtered off or something. And then I'll hardcode the file names, because that's what we do here. We hardcode file names. Or I think this was unigrams. What I can also do is, yep, there we go. Yeah, sorry, UK word, unigrams, as FP. And so I'll have unigrams equals an empty dictionary and bigrams equals an empty dictionary, and then I'll have Unix equals an empty set. And so, yep. Or for line in FP, unigrams, well, okay. So fields equals, what is it? Oh yes, right, it's line dot split. Well, first I want to do a strip, and then I want to do a split. If when fields is equivalent to 0, continue, and then unigrams. Or wait, no. Wait, yes? Yes, 1 equals 0. Because if I look at it right now... Yep. So the numbers first, and then the actual word is there. Copy and paste that. Do I want to do a tuple or the same thing as last time where I did an addition? I think I can do an addition. I think I want to also do a lower here, yeah. Lower. Lower. No. Yeah, I want to do a tuple here. Yeah. I think equality comparisons with tuples check both of these, if I recall correctly. Yep, so that should work. And then with open... Was it Unix sort? Yeah, it was Unix sorted. As FP. Then Unix dot... I forgot if it was add? I'm gonna Google something real quick, yeah. Python set add? Yeah, it's just .add, okay. Oh, and then for line in FP. Line dot strip dot lower. So for word and priority in unigrams, right? Yeah. If word in Unix, then what I'm going to do is print word prio? Or no, prio word, right, because that was what we had before. Yep, prio word. Ah. I did not want to do that. Okay, that was interesting. So what does it filter? Oh, come on. What's that? filter. I think I also, yep, I need this. Wait, shoot. Oh, okay, right, yeah. Because, like, it's not just Unicode, apparently. So... Sure, we'll do an RV. Why not? I think there was also a way to do a lossy conversion. I'm content with just doing a lossy conversion and leaving it at that. Python decode lossy. Again, I'm googling this real quick. Errors equal ignore. Okay. So I can say UTF-8 errors equal ignore. Nah. Yep. So that works. Okay, so hopefully that goes better. List index out of range. Wait, out of range? How is it out of range? Oh, because... Okay. So I'll say... so not equivalent to 0, but like less than 2... Yes. Oh, so then less than 3... Right, so I don't want that. I wanted to do bigrams. Bigrams! That one's also kind of a long... Okay. We'll skip the bigrams, actually. So the unigram should take some time, but not as long of a time. Uh-oh, too many values to unpack. Oh, dot items. Yeah, so... Let me also do less here. Just so I can scroll through that a bit. All the priorities are just 1. That should not be happening. Because, like, if I look at sorted, there we go. Yeah, like we have that's a very high priority. We should not be having that low priority. What are we even doing? Sure, we'll print this. Actually, better idea! Python has breakpoints! Let's just use those! So what is it? P unigrams. Right? Okay, so that's actually doing fine. This is actually what I expect. Yes! Okay, so that's actually not the problem. The problem is here. So this is going to take some time, but then eventually we're going to get in the debugger and we can actually figure out what the heck is going on here. P word prio. What? That's ridiculous. Rigged. P unigrams. Oh, so that's going to take some time. What in the world? Okay. So wait, not all of them were just one. So this is confusing, right? There is sort of this expression. What is it? Word prio for word prio in unigrams items if prio does not equal 1. Oh, come on. Yes, I did. Oh, right. Okay, I forgot. Yes, you need this. Or I guess also here. Yeah, so not all of them are 1, so I'm unsure of why some of them are not 1 and others are 1. I'm definitely overwriting something. Oh, yeah. Something's being overwritten here, for sure. So I'm going to see if word is equivalent to the... Then I'll do a breakpoint. Because this is the only way it should actually be set. Oh, hold on. Okay. So that's weird. Wait, so there's multiple of those? Why on earth would that be the case? P word prio. Let me also do line. What in the... Oh, fun. Okay. Wait. Okay. Shoot. Yeah, that's a very interesting assumption. Okay. What is it? Oh, word set unigrams. Okay. Yeah, okay. I actually legitimately thought that all the words would be lowercase. I think they even like set that on the site. That's weird. Okay. But yeah, so I can sort. So if my hypothesis is correct, Should eventually get to like the ones. Or I could just keep going here. Oh, and the case is even exacerbated by the fact that I chose a lossy conversion, so sometimes it literally just is not there. Okay, that's interesting. But yeah, I can deal with this. So what I'll instead do here... Okay. Equals unigrams dot get word 0 plus prio. That works. I also want to do less just to confirm things. Yeah, so now you have a much more appropriate list. Okay, so noted. It looks like I will also have to clean this list a little bit. Because, yeah, you just get some really weird results if you don't clean a list. But yeah, that works. So I need to do the same thing here. By the way, so what WaCKy stands for is, what is it? Oh yes, like web as porpoise, and then there were some things after that. So part of this was web scraping, so you can see some weird stuff here, like they have paths in there. It still looks like a pretty good, like just a reasonable corpus though. So what is this? Bigram. Bigram equals bigrams.get. I want addition here. Take that. Field, or not fields, but bigram. Yep. Bigram. Again, we'll do a similar thing. In case we have like two of the same bigram, that's not, which isn't a common occurrence, but again, it messes things up, so we want to take care of that. So what I'll do here is I'll put it in ngrams filter .txt. So this will take a while, but it should be done fairly, like it wasn't an unreasonable amount of time before, so it should be fine. Or wait, I forgot to even include the bigrams in the file! No! RIP, okay. It was still even getting the bigrams in the first place. Funny. Okay. So now for bigram, prio in bigrams.items. W1, W2 equals bigram. If W1 in Unix and W2 in Unix, print prio W1, W2. There we go. That should work. I say there we go, but there have been so many times in Python where I just am kind of scrappy like that and I don't do type annotations, and so I make like stupid little mistakes where you don't catch it until like a few seconds after it's done. This might be one of those times as well. I want to see TL go for once this is actually done. It should be done soon. Hopefully it's done soon. I remember it was... I thought it was faster before. I don't know what happened. Okay. Maybe it was always this slow. Who knows? What else can I do, though? I mean, maybe I can sort of look here. Sort of gather my my bearings as to what's happening here. Okay, so once that's filtered... Yeah, so I want to actually deliberate how I'm going to actually do the bigrams. Yeah, so I already have these prefixes, and that's pretty neat. So now, what I think I would like to do is do this bigram here. And so I can do find... Or actually, I want to go through each of the words here. And then... So then prefix bigrams, or bigram. So I want to find bigrams, and so what I want to do is then do words sorted, but then I want to do sentence lower I plus len prefix, or len word, colon, and so what that'll essentially do is like look at the rest of the sentence after the word, and then I should be able to try out each of those prefixes and then see what sticks. Oh yeah, there we go. Yeah. Look at that. Look at that. Look at tail going brr. Yeah. There's a lot of these. Makes sense. Okay. I think the fact that... Hi, Vengeance. I'm doing well. How are you? I'm just apparently watching Tail Gober. Okay. Let me do less instead. Okay. So what I'm doing, so how am I? Yeah, I've been doing just overall well. I got back from work and I just went straight into this. Hi, Lisa. So what I'm doing right now is, let me start up the bot when I next get the chance. Yeah, let's do it right now. So I'm making a Twitch bot, and so I say good day, and what I'm making is I'm separating this sentence out. So you prefix my name, and I don't know, you say something like, please, let me have a good day. And it's supposed to separate it out more reasonably. It's supposed to separate it out like that, and so I'm still working on it, but it's supposed to say, like, have a good day, essentially. So it's just something stupid like that, where just an overall interesting problem of, oh, if I merge this sentence together, like that sometimes happens, how do I separate it out? How do I have a computer separate it out? So that's what I'm doing right now. And so there were some things I initially tried. Is it still going? It's still going. Okay, nice. So there's a few certain optimizations that, well, not optimizations, but there's a few things that I'm doing to even do the algorithm in the first place. So let's take, again, our example of have a good day. So what I'm essentially doing is I'm using this string and then I'm searching. What I'm doing is I'm like searching for prefixes. So I'm searching for prefixes of have a good day, I'm searching for prefixes of have a good day, I'm searching for prefixes of be a good day, searching for prefixes of be a good day, etc. If I find a word like have is a pretty good prefix, so then I advance it in advance, and I just move on to a good day. That's essentially what this program's doing. And so that's initially what I was doing, and I was just looking at what are called unigrams, so that's just a unit of words. So the unigrams in the sentence are have a good day. Those are the unigrams. What I'm trying to look at next is bigrams. So I want to see what bigrams are most frequent. And so have a is a pretty frequent bigram. And so if I look at my original one, what I had to split was have a go, odd day. That's not really a usual bigram. However, have a is a more usual bigram. A good is a more usual bigram. Good day is a more usual bigram. So if I were to actually look for more common bigrams, instead of, I think for this one I did longest prefix. I also tried to do it by priority, and that didn't work out well either. But if I instead stop looking at unigrams and I look at bigrams, I think I would have a lot better results in terms of breaking up the sentence. So that's what I'm trying to do right now. Great, and that's filtered. So if I go down here, yep. So I have these bigrams and unigrams right here. Yep. And what I did here was, the original list was really big, so I wanted to filter it so that it only included words in, say, like the Unix dictionary, because that's a lot smaller than the corpus I had before. So let me see if that actually does it better now. So what is it called? Filtered n-grams? Yes. N-grams filtered. N-grams equals space N-grams filtered. Oh, by the way, I never asked you how you were doing, Lisa. How you doing? Prefix by... Oh, that's true. I didn't use it. I was planning on using it eventually. Prefix bigram. So now I'm reading the words. Let's see how quickly this goes. Hopefully less than 30 seconds. like it was last time. Okay, it's about like 15 seconds. I'll take it. Wait, but that's a long time for, what was it, 76,000 words? Yeah, no, that doesn't seem very cash money. So I might be screwing something up that's just really screwing with the complexity. Yeah, because I have that. It was definitely a lot less. So, what was it before when I did this, actually? That was actually quicker, and it had more words. Okay. Huh. So definitely something is... What might have been the reason it took so long is because I'm actually screwing something very, very wrong right here. Or what are the line counts here? Oh, you know... Oh, shoot. So what it might be is that... So we have about 4 million entries. But what it might be is that I did a certain optimization before, which was that... Yes. So what I did was a process called limitization, just to go over that real quick. With Chrome. Yes. So limitization is basically... Let me see if I can see that clearly. Nah, I think I need to zoom. I need to select the image. Okay. LinkedIn. Okay, sure. Whatever. Can I just see the picture? Okay. Also, that is my actual LinkedIn account. I don't want to look at that right now. Okay. Oh. Okay, thank you, chat. I hate this. I really... Okay, let me just really zoom in. Okay, never mind. Okay, Can I just copy the image address? I just want to look at it. Thank you. Yes. So lemonization is just taking these words and putting it into the root word. And apparently what I did was so effective that I was reading a lot of lines of the file, and the lemonization actually filtered a lot of those out. So I need to take care of that again. So it looks like I might need to make another Python script that reads these sort of lemmas and does the filtered list. Okay. Okay. Yes, so we'll do filter2.py. So there's filter dot play. There it is. Word list equals this. Okay. So with open n-grams filtered, okay, so I don't have to do that anymore, so I can say for line in FP. The reason I don't have to do the binary anymore is because this word list needed cleaning, and so I converted from binary to Unicode. And I did it lossily, so I didn't have to think about it much. Fields. Line.strip.split. Again. So if it's less than 2, then I continue. Field sub 1 dot lower. Field sub 2. Or not field sub 2. I wanted an empty string, and then if len fields less than 3, or not less than 3, but like greater than or equal to 2. Not greater than or equal to 2, just greater than 2. Then w2 equals fields 2 dot lower. Oh, first of all, I want to not do this yet. I first want to read the lemma. This with open lemmatization. Yep. Lemmatization. En.txt as FP. For line in FP. Fields equals line strip split if len fields less than 2. Continue. Oh, that actually reminds me, let me go back to the uncombine. So I had lemma, but I think strings dot. I want to lowercase all the fields. I think in the lemmatization list it's already lowercase, but just to be safe. Or if it's even less than 1, yeah, if it's less than 1. No. In other words, equivalent to 0. Let's just say that. Let's just say if it's empty. Dot lower. If for word in fields. Word 2 lemmas. Yeah, I like that one better. Word 2 lemma. Well, not lemmas. Word 2 a lemma. Word equals lemma. Word dot lower. Yep, there we go. So then if W1, or if W2 is an empty string, then I just want to... Oh, that's right, they have priorities actually, so I want to check if it's less than 3, because there should be at least 2 fields. Prio equals int. Yep. So then if it's less than 4, or if it's greater, no, if it's greater than 3, yeah. Then I want to print prio w1, else or wait, no, I think I did like a map here. So I'll do bigrams again. Or the same thing where we do unigrams and bigrams. Unigrams w1 equals prio, else bigrams w2 equals prio, or w1 w2. Yep, w1 w2. Make that a tuple. Or no, I want to convert these to their lemmas. Yes. So with unigrams, I don't want to change them. With bigrams, I want to convert it to the lemma. So bigrams, or w1 equals, what is it? Yeah, word to lemma dot get w1 w1. Same thing with here. So w1 w2. Oh, and then yep, equals bigrams. Oh, and then bigram equals w1, comma w2, bigram. What is it? 0 plus prio. Yeah. Because at this point there might be duplicates. Do I want to do the same thing for... Yeah, I might as well, just to be safe. W1 equals unigrams dot get w1 prio plus prio. Well, not prio, but 0. Yeah, so that should be fine. For bigram, prio... Well, not... Okay. Actually, now that I think about it, I might just be wasting my time, because... Why? I could have changed this specific file to be my ngram. Yeah, ngrams. Well, no, I can't. Oh, right, and then they're combined. Okay, yeah. I was thinking I might have been able to change this file names just to do it, but no. For unigram in unigrams. Well, not unigram, but we'll say word, comma, prio, and unigrams.items. Print prio word, and then for bigram, prio, and bigrams. items. Print prio w1 w2 equals bigram w1 w2. Nah, I actually kind of like just doing bigram 0, bigram 1. Yeah, let's just do that. Filter 2. I wonder how long this is going to take. It shouldn't take as long of a time. There should be a lot less words in the list. I'd say give it less than a minute. Yeah, there we go. Yeah. Wait, but there's no bigrams? What? That is sort of what it looks like. It looks like there were just no bigrams. So if I hit a breakpoint, if I don't hit a breakpoint, then there was never a bigram in the first place. Which should be the case. Yeah. So there's never. So why is there never a bigram in the first place? So wait, what happens if it's greater than 3? Then there are 4 fields. Oh, wait, yeah, that's true. That's not what I want. So I do want greater than or equal to 3. Wait, so if it's less than 3... Would it be less than 2 then? Yeah, it's less than 2. Because I just... Yep, okay. I'm being dumb. Now I should hit a breakpoint. Yep. P line, P, W1, W2. Or, okay. Pio, W, or... Oh, wait, I think they're not even there yet? No, they're there. Pio? Yeah, there we go. So now let's do that again. And now everything should be proper. Yep, great. Okay. Ngrams filtered to .txt. Okay. So I read words and I use the lemmatization to do that. And so find prefixes. So when I'm splitting the sentence, it looks like I'll need an extra parameter. I want the bigrams instead of just the words. Except I'm not using the bigrams yet, but we will eventually. We'll say dash equals bigrams. So that's technically used. So Go will not bitch at me. So I can say bigrams. And then the word list is there, the bigrams is here. Let me see. Yes. WC-L ngrams filtered to. That still looks like a lot. It is less. And it did do it much quicker. Wait, I think I was using the Unix list though. Yeah. So it should do it in like 5 seconds. I think it was like a third. Or was it a half? It's still like 70, yeah, it's still like 76 to 20. Wait, what am I doing differently? What the heck? Because like 2, yeah, 2 has many more words than that. Huh. Yeah, I'm very much, Okay, so I have to make a quick decision. Is it the Go code that might be doing something wrong, or I am... Or the Go code that's doing something wrong, or the Python code? Okay. Oh, wait, yes, I am doing something wrong, which is that... Okay, so I have all the unigrams, but I didn't count the bigrams. So how many bigrams are there? A lot of them. There are a lot of bigrams. Oh no. And I think I had... Did I mess something up in the Python code as well? I might have, because it seems like I filtered more in the Go code than I did in the Python code. A little bit, but maybe we look at that a bit later. But yeah, so I have a lot of unigrams, but not a whole lot of bigrams. Okay. Or I have a lot of bigrams, but not a whole lot of unigrams. I think, I might have not gotten strong results from that, actually, in terms of, like, runtime. So let me try the original one again. Yeah. Because I think the other one took like 20 seconds, and this one takes... And like the other one took like 12 seconds, so that's 12. Yeah, I don't think I got strong results from that. And I also got a different word count. Okay. Yeah, I think I'll go with this one. Because what was it? Yeah, I don't think it increases the... I also wonder how much the runtime is going to be impacted. Because this is like 27 million... Ugh. I think on the bright side... What I'm suspecting is that it might not be a big deal, like, for maybe prototyping, yes, this is a bit of a big deal, the fact that it takes so long. I think even then, like, the time that I took to sort of automate this might not have been worth it. Which, oh well, sometimes you take the L there, but... Uh-oh. Connecting to chat. Is stream doing fine? Okay, yes. Stream's still doing fine. Cool. Yeah, so sometimes you just take the L there. Sometimes I have a gander that, oh, maybe it would be good to make this more... decrease the data here, but sometimes, yeah, you just waste a bit of time there. This was one of those times. But I think what I did, which was good, was that most... So what I actually want to do now is that... Okay, so what I identified was good, because what actually happens with the algorithm is that the algorithm scales much worse with the unigrams than it actually does with the bigrams. Because what I'm going to do with the bigrams actually is that the bigrams... So what I'm going to do with the bigrams is I'm just going to do like, okay, so I have these prefixes, and then I'm going to say like, oh, I don't know, for P1 in prefixes, this is pseudocode right now, so don't worry about it too much. For P2 in prefixes, bigram. I'm gonna say bigrams P1 plus space plus P2. I'm gonna say look up this bigram. And that's it. That's all I use the bigrams for. And maps are just basically hash tables anyways. So the runtime is actually really efficient here. It should be really efficient for bigrams. It's just the reading that's a problem. However, it's the finding of the prefixes that's like... I think I made the algorithm to be log n or something. So that matters quite a bit. Well, not quite a bit, but it like matters non-arbitrarily. And so anything I can do to decrease the unigrams is actually what I really want. And for bigrams, it's actually not that big of a deal. So it's good to recognize that there's actually, unsurprisingly, there's just much more bigrams than unigrams. Because bigrams are less of a pain point, but unigrams are very much a big pain point. Okay. I think I'll say this is prefixes 1 and prefix 1. And this is not prio, but maybe n-gram prio, yeah. Colon equal range prefixes. Prefixes 1. And then for P2, in range, prefixes 2. Yeah, so I had this... Oh, wait, first I want to make them lemmas. Yes. Lemmas, map, string. So this is bigrams, add another one, lemmas, and so what we do with the lemmas is I say lemma 1. I do pretty much a similar thing up here. In fact, because I sort of do this twice, and it's kind of a very portable operation, I'll just say bigram to lemmas. I'll make a new function here. W1, W2 string. And then I say string. Map, string. Okay. Yep. So we'll say this is and then lemma 1, lemma 2 equals bigram 2 lemmas word 2, and then lemmas. W1, W2. I actually forgot if in Golang you can provide like a default value. I don't remember you being able to do that, but in which case this might have been able to be made shorter. But either way, this is fine. Yep. So bigram to lemmas. So I have a word and I could also say key. Yeah, let's do this. And then this is a string. So then I could say bigram to key. Word 2. Lemmas. Now there's no way I can possibly screw that up, and I can change how I do that. Not that it's very important to change it, but again, no way to screw it up if I just say bigrams, or bigram to key. What is it? Lemmas. If okay. Did I say we were... Oh, I'm already doing this. So I want to give priority to bigrams and then fall back on unigrams. If prefix to equals append sentence words, so this is prefix 1. Yeah. Huh. Sentence I plus len, prefix 2, Actually, I don't have to do this assignment of anchor to I. It's done after this anyways. Yep, so we'll just append that. So say prefix is 2, and then I go through the words. Word 1. We'll say this is word 1. And this is word 2. So I'll say here if prefix 1. Yeah, so I want to give priority to bigrams. So if it's okay, and yeah, I want to do this priority search right here. Prio 1 equals word, or not words. Bigram key. Oh, right, so it's priorities. Okay, so this time I don't think I'll do like longest prefix matching, but yeah, I don't think I necessarily need to do that. Yeah, I think I was doing this before because I used to have like another word list where, yes, most of the priorities were 0, so that mattered, but it doesn't really matter anymore. Yeah, no. So if it was okay, and the priority is greater than the prefix, or is greater than n-gram prio, then prefix 1, prefix 2 equals word 1, word 2. Or wait, no, I think... Yes, that should be good. And then n-gram prio equals prio. So then if I didn't find anything there, then I'll do this path. Yeah, then I'll go down this path of just, yeah. Yes, then I'll say forward in range prefix is 1. And then here. Again, it's not that deep, so I don't care about this. Let's just check the priority and be done with it. So then even after all of that, if I didn't find like a good unigram, then I can cry myself to sleep. Okay, what is it? 164. So do I want to say bigram? Oh yeah, I can just say that. Prefix file ngram file prefix 175. Okay, so then that takes a few seconds. Should take about 15 seconds, I think it was last time. Hello world. I'm not crying, you're crying. Really? H and E? That doesn't seem... Oh wow, that actually is apparently a common bigram. Why that's a common bigram? I don't know. Is that seriously something that shows up in UK lemma diagram? Okay. Okay, I'd rather use riprap. Yeah, that is one of the bigrams of our time. Sure, so that's... okay. So I am identifying common bigrams, apparently. Hello. Really? Is that not a common one? Apparently not as common as H and E. Okay. How are you doing? What even is this list? You're joking. You're actually joking. Okay. Okay. I am invincible. Damn. This is very weird. Okay. I still think this is the right idea, it's just I might have to actually filter the word list. Because some of these bigrams are kind of stupid. And apparently they're showing up as actually quite common. Really? More common than I am? No. That was not more common than I am. Oh, that's my SSH into my server. So that is an inaccuracy. Also print out the priority, just to make it easier. Okay, so I am doing some sort of programming error. Because I am should have been much more common than I am, you know? Yeah, you get it. Yeah, this is 3? No shot, dude. Wait, 3? But this is 36. Yeah, still incorrect. So Better engram. Oh snap, we got... Damn it! Banned. And take a bit of time to report that. Spam. Scam. Unusual message. Hyperlink. Block. Okay. Better bigram. Oh, why wasn't I am in there? Fuck. Okay. This is a bit frustrating. I might deal with this more tomorrow. I swear, this is sort of the right idea, so... And it was genuinely increasing, it's just for some reason I am wasn't a prefix? Even though I is definitely in there. So I have IA. I have I. No, wait, so I have IA. What? How did I not find I? Why do I have multiple IMs? Or why do I have IM? What? Peptile. Wait, whoa. Okay, that actually worked. Strange. Okay. There's bugs farther than the eye can see. It's just how it is. Oh, wait. So actually, this is interesting. There might be some unigrams that are more common than the bigrams. So I might want to actually look at that. So I don't imagine this is very common. Whoa! Got a power. Thank you. That's it. Thanks, Askin. Really appreciate it. But yeah, sort of. Yep, sort of having fun doing a bunch of stuff with unigrams and bigrams. I was, yeah, I'm trying to like sort of split up the sentence. It's like sort of working right now, but yeah, I just got a lot of bugs. I got bugs. So IN is there. Wait, and that's strange. It's not even like the most common bigram, I think. Yeah, it's not really even that common of a bigram. Oh, wait, but it was for, like, the thing that we had. Okay, so I think... Wait, was one of them, like, 5,000? Oh, wait, no, that is still a more common bigram. Because I would have thought Invincible is just a lot more common than I and End. Honestly, I might want to like get rid of the like one letter things that aren't like I or A, because that's not a thing. And you can't convince me it's a thing. You just can't. Okay. What about am invincible? Oh, that's actually surprisingly not common. That's not common? Really? Okay, sure. Okay, but I am curious. I tried I love you before. Let me see if that one's better. It's sort of better. It was worse before, believe it or not. Yeah, so I love is a very good hit. Okay. So what I might also want to do is look at the bigram previously to make that result a bit better. Because, like, love you should be a very common bigram. Yes, love you is an extremely common bigram. So, it's not a bad idea to actually first of all, I think I want to commit this, because this is kind of a lot. Yeah, this is already a lot. So, gonna commit it so that I don't lose it. Yep, okay, there you go. Use bigrams to improve parsing. Okay, nice. So now we'll take a look at looking at the previous word, and then I can establish some priorities based on them. So I have sentence words. Yes. So if when sentence words does not equal 1, So if end sentence words does not equal 1, or not equal 1, but if it doesn't equal 0, then I can use the previous one. Or I guess I can also put this in the inner loop. Yeah, probably better in the inner loop. Prev is sentence words. Len sentence words. -1. So I want the previous word I got. And so bigram. Yeah, so I don't want to print this anymore. I think my bigrams parsing's better this time. Maybe I still want to print. Nah, I still want to print it. I'll even print it up here. Why not? Prev, prefix 1. Lemmas. Prev, prefix 1. Prio. Okay. Bigrams. Bigram. Oh, did I say engram prio? I think I meant prio. Yeah, I meant prio. Or no, okay. Probably here? Yeah, sure. Oh, yeah. So put it here. Yep. If okay. Prio is greater than engram prio. Then prefix 1, prefix 2 equals word 1, but then I'm going to do an empty string here because I don't want to append that prefix. I want it just to be the unigram. Do, 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 do. Okay. Yes. I think I still want to give greater priority to bigrams over n-grams, even if one n-gram is more frequent. Maybe. Yeah, who knows? No, I think I do still want to do that. Okay. Test. Okay. This is going to take a while to read. Let me just write out the message. Okay, oh, rip. So I should have gotten love you. Let's say... Printf debugging, yay! Okay. Prev. Oh. There we go. So I do have prev. Sure, we'll try for your first one. I love yo, yo, yo. So why didn't I find you? Is the thing. Yeah, why didn't I find you specifically? Even though it is part of the unigrams filter. Imagine loving YouTube. That's crazy. Also, hi YouTube. Okay. This is getting a bit tough and it's going to require a lot of debugging, so I might save that for later, because it is getting late now. Well, this was fun. Actually, this is fun, because I think this is promising. I think this is actually going to make the separation better. So I look forward to doing more with that. Just now it's late, so bye everyone. Thanks for sticking around, and see y'all later.